There is this beautiful theorem in physics, the CPT postulate. Pretend you switch all the electric charges, you look in a mirror and reverse the arrow of time itself. All the physical laws will not change, and our universe would seem identical to that in which we find ourselves. But any one or two changes by themselves will produce a universe different from our own. C violations and P violations have both been observed, and CP violations were found more than 50-odd years ago. T violations have yet to be seen, until now. This work was done using neutral B Mesons at Slack. You should know that these neutral B Mesons will oscillate between their two different flavors. So, B Meson, anti-B, B Meson, anti-B. Slack creates pairs of them. We cannot see all these mesons directly. We can see what's left behind when they decay. So the B meson gives us a positron plus some stuff. Anti-Bs give us electrons and stuff. Look at what comes out, and if there's electrons and other stuff, with correct energies, momenta, you conclude there was an anti-B meson there, and the same thing with the positron signaling B mesons. But there are some decays that produce different things, kaons and J/psi particles. Such decays must come from states that are mixed, that is, linear assemblies, Bs mixed with anti-Bs. Mixed states are odd, but describe the B mesons just fine, so we have to accept that they're equally physical. Thus we can label the starting state B, anti-B, or B plus and B minus. The oscillations from before will allow the B state to become B minus, and B plus can turn into an anti-B or any other such conversion. But as the brilliant Marie Carmen Banuelos has shown, such a conversion can be affected by B oscillations, and therefore depend on the time. So a forward conversion will not always happen as much as a backward conversion will. This is the T violation. They looked for two states that decayed to Bs, where at first there was just one B minus decay that was followed by B decay. Then they compared with decays that involved a B first, then B minus. They saw there that one of these processes happened more frequently. This is the T violation. They next did the same thing for B and B plus, and for anti-B decays as well, and they saw the same thing. What does this mean? Well, the big result's not too surprising, that physics does not work identically forward and backward in time, and I say this more deeply than any old arrow of time tale about eggs unbreaking themselves. The statistics of millions of atoms gives entropy, which is why eggs can't be unbroken. No, this experiment showed us a separate arrow of time, one from particle physics. The fact these two arrows are parallel, that is a clue there's a connection between the large-scale view of our universe and, on the other hand, particle physics, which describes the small-scale world.